In this concept, we're going to talk about factoring the difference of squares. And the difference, or a difference of two squares, is essentially two terms that are squares of something that are subtracted, right? A squared minus b squared. And these always factor out to this form, a plus b or a minus b. Or you could have said a minus b times a plus b. Again, the order does not matter because of the commutative property of multiplication. Okay? So let's look at an example. Factor x squared minus 49. X squared minus 49 is a difference of two squares. X squared and 7 squared, right? So this is going to give us x plus 7 and x minus 7. Right? Very straightforward. Let's look at another example. Factor 63a cubed minus 7a. First, we can find the greatest common factor of both terms, which in this case is 7a, right? If we factor 7 from 63, we get 9 left, so 7 times 9 is 63. So 63a cubed becomes 7a times 9a squared, and then factoring 7a out of 7a gives us 1, right? So here we have 7a times 9a squared minus 1. This is an a, not a 9. So 9a squared minus 1 is a difference of two squares, right? Well, what is the square root of 9a squared? So 9a squared, the square root of it is 3a, right? So 3a squared is 9a squared. And then 1 is, a square of 1. So 3a squared minus 1. Right? So to factor it out to the form a plus b, a minus b, we'll get 3a minus 1, and then 3a plus 1. And then we had the 7a factor outside, right? So we just write it out. And this is our answer, just like we have here. Okay, let's look at another example. Factor 2x to the fourth minus 32. So 32 in and of itself is not a square of any whole number. However, when this is the case, try to reduce it further. Again, it's all about trial and error. So try to reduce it. Let's see if we do factor out the greatest common factor. Let's see if it becomes a square of a whole number, or of something that's not irrational. 2, we have a 2 here, and we have 32. So let's take out a 2, right? Let's factor out a 2. So we'll have 2 times x to the fourth minus 16. So 16 is a square, right? So is x to the fourth. So we'll get 2 times x cubed plus 4 times x squared, and then times x squared minus 4, right? Which is exactly what we have here. Okay? However, when you look into each one of these, notice that x squared minus 4 is also a difference of two squares, right? So this is going to give us x minus 2 times x plus 2. So the final result is 2 times x squared plus 4, which can't be factored out any further, but then x minus 2 and x plus 2. Okay, which is exactly what we have down here. Let's look at another example. Factor 2x cubed plus 8x squared minus 2x minus 8. So factor out the greatest common factor, which is 2. In this case, it's 2. So that gives us 2 times x cubed plus 4x squared minus x minus 4. Group the terms with common factors, in which case we have the x cubed and the minus x, right? Group these together, and then plus 4x squared minus 4. Group these together. Again, factor out the greatest common factor. In this case, it's x. For these parentheses, it's x. So x times x squared minus 1, right? Because we factored out an x. And then here we have 4, right? 4x squared minus 4, we can factor out a 4. So x times x squared minus 1 plus 4 times x squared minus 1. Then we can actually factor out the common factor x minus 1, right? We have x minus 1 here and x minus 1 here, x squared minus 1 here, x squared minus 1. So that gives us 2, right? And then x squared minus 1 times x plus 4. This is a typo, right? This should be multiplication. Okay, this should be a multiplication sign. So, and then notice x squared minus 1, this can be factored out further, right? Difference of 2 squares. Again, x squared and 1. So this is going to give us x plus 1 and x minus 1. So the final result is the product of all these terms. So 2 times x plus 1 times x minus 1 times x plus 4. And this is the result. Okay. Here we have some exercises. Please pause the video, work on these, and come back for the solutions. Okay, x squared minus 36. This is very straightforward. Open two parentheses. X squared factors out to x and x. 36 is 6 and 6. And then just plus and minus. Very straightforward. 9x squared minus 1. Again, open pair of parentheses. 9x squared is 3x and 3x, right? 3 times 3 is 9, x times x is x squared. And then 1 is just 1 and 1. And then just plus and minus. Very straightforward. Let's look at this one. 3x cubed plus 6x squared minus 15x minus 30. So this in this one we would have to use the grouping method that we discussed in the last example. But first we can take out the greatest common factor, which in this case is 3, right? 3, and then 6 is divisible by 3, 15 is divisible by 3, 30 is divisible by 3. So we have 3 times x cubed plus 2x squared minus 5x minus 10. And then what we could do is we can we can group some of these terms, right? And again, grouping is based on trial and error, just like many other things. Here we could use x cubed plus 2x squared, and then we'll have minus 5x plus 10, right? So 3 times, so x cubed and 2x squared, we can factor out an x squared, and then we'll have x plus 2, and then minus, we can factor out a 5, right? From 5x and 10, we can take out a 5, and then we'll have x plus 2. Excellent. So now we have x plus 2 and x plus 2. So we can factor out that x plus 2 to get, so we have 3 times x squared, well, actually 3 times x plus 2, factored it out, and then we would be left with x squared minus 5. X squared minus 5. Right? Or just 3 times x plus 2. This is a plus sign. Three times x plus 2 times x squared minus 5. Okay? Okay, hopefully this is clear. This is it for this concept. See you in the next video.